Maximum power transfer answers a very practical question. Suppose everything to the left of terminals A and B is fixed, and only the load resistor can be chosen. What value of RL makes the load receive the largest power? The common wrong instinct is to say, make RL very small so the current is large, or make RL very large so the voltage is large. Both instincts miss the trade-off. A tiny load gets current but almost no voltage. A huge load gets voltage but almost no current. Maximum power happens in the balance between the two. We replace the left side by its Thevenin equivalent, that is, a voltage source Vthevenin in series with Rthevenin feeding the load RL. Now call the load value X. The current through the load is Vthevenin divided by Rthevenin plus X. The load power is I squared times RL. So substitute the current. P equals Vthevenin over Rthevenin plus X squared times X. In one line, P of X equals Vthevenin squared times X divided by Rthevenin plus X all squared. To find the best X, differentiate P with respect to X. Vthevenin squared is a constant, so it stays outside. The derivative reduces to Vthevenin squared times Rthevenin minus X divided by Rthevenin plus X cubed. For a maximum, set the numerator to 0. Rthevenin minus X equals 0, so X equals Rthevenin. Since X is the load resistor, the rule is RL equals Rthevenin. Then the maximum power is Vthevenin squared divided by 4 Rthevenin. This is the rule to remember. Match the load to the resistance seen from the port. Now use the rule on the example. The question is not asking for the current first, and it is not asking for an arbitrary load. It asks, what RL gives maximum power between A and B? So we need two things from the network with the load removed. First, Rthevenin seen from AB, and second, Vthevenin, the open circuit voltage at AB. After those two numbers are known, the answer is direct. RL equals Rthevenin, and Pmax equals Vthevenin squared over 4 Rthevenin. Start with Rthevenin. Turn off the independent sources only. The 12-volt voltage source becomes a short circuit. The 2-amp current source becomes an open circuit. Looking in from A and B, the 2-ohm resistor is in series with the 3-ohm resistor. After that, the 6-ohm and 12-ohm resistors are in parallel to the bottom node. Compute the parallel part. 6 times 12 is 72. 6 plus 12 is 18. 72 divided by 18 is 4 ohms. Then add the series resistors. 2 plus 3 plus 4 equals 9 ohms. Therefore, Rthevenin is 9 ohms, and the maximum power load will also be 9 ohms. Next, find Vthevenin. Remove RL so the output is open. Because the output is open, no current flows through the 2-ohm resistor. Therefore, there is no voltage drop across it, and the terminal of voltage equals the top middle node voltage, Vthevenin. Let the node between 6 ohms, 12 ohms, and 3 ohms be V1. At the Vthevenin node, the 2-amp source injects current upward, so KCL gives Vthevenin minus V1 over 3 minus 2 equals 0. That means Vthevenin minus V1 equals 6. Now write KCL at V1. Current through 6 ohms is V1 minus 12 over 6. Current through 12 ohms is V1 over 12. Current through 3 ohms is V1 minus Vthevenin over 3. Add them and set the sum to 0. Multiply the whole equation by 12 to clear denominators. We get 2V1 minus 24 plus V1 plus 4V1 minus 4Vthevenin equals 0. Combine like terms. 7V1 minus 4Vthevenin equals 24. Together with Vthevenin minus V1 equals 6, solving gives Vthevenin equals 22 volts. Now combine the two results. For maximum power, RL equals Rthevenin, so RL equals 9 ohms. For the maximum power value, use Pmax equals Vthevenin squared over 4 Rthevenin. Substitute the numbers. Vthevenin is 22 volts, so 22 squared is 484. 4 times Rthevenin is 4 times 9, which is 36. Then 484 divided by 36 is 13.44 watts. That is the largest power this network can deliver to a purely resistive load. The whole method is short, but the order matters. First, convert the rest of the circuit into what the load sees. Find Rthevenin with independent sources turned off. Find Vthevenin with the load open. Then choose RL equal to Rthevenin. If the question also asks for power, use Pmax equals Vthevenin squared over 4 Rthevenin. In this example, Rthevenin is 9 ohms, Vthevenin is 22 volts, and the maximum load power is 13.44 watts.